Hello, and welcome to the video presentation of my CIS 4900 project. My name is Francis Harbord, and this is Tarnished Crown, a turn-based tactics RPG that I built this semester. Everything you're looking at, the lighting, the terrain, the effects, the UI, all comes from a custom shader pipeline and a handwritten system stack that I wrote from scratch in Unity. I want to walk you through 4 pieces that I'm most proud of: the terrain shaders, the environmental effect shaders, gameplay feedback shaders, and the systems architecture that sort of unites it all under the hood. Before we dive any deeper, though, I want to quickly go into the primary motivations and inspiration for this project. And to do that, I will enlist the help of a slide. Firstly, I wanted this to genuinely showcase what I've learned across this degree. From algorithms and data structures, to coding fundamentals, to systems design and architecture, and basically building a code base that holds up as it scales. And secondly, I wanted a creative outlet, a chance to actually apply all of that knowledge to something visual and playable, not just leave it as an abstract skill on a transcript. That's why everything here is written from scratch. There are no shader libraries or asset store shortcuts. That would have sort of defeated the point. I scoped this to one polished battle encounter across 4 visually distinct biomes that you'll see, and each of which are fully procedurally generated and tunable in the editor. This project was broken into 4 major milestones some of which I mentioned before: the terrain shaders, the environmental shaders, gameplay feedback shaders, and post-processing. All 4 are complete, and I even had time to add a spell system and a bit of extra UI work that I'm fairly happy with. So that's the state that the game is in, and we'll jump back into the editor to kind of show off some more of that. So as you can see, this map is being rendered in real time. And here are the player characters down here, and here are all of the enemies over here. But before we do the full gameplay demo, I just kind of want to break things down and show you how everything is kind of working in the editor. So we'll zoom out a bit and do that now. So structurally, a battle state machine drives all of these manager classes, and we have one for sort of everything: a movement manager, a camera manager, selection manager that handles selecting tiles, the state manager that handles all of the game state, turn manager for player turn, enemy turn, combat manager, AI, on and on. And they all reference each other, or some of them reference each other where needed, via references that are exposed in their C# classes. So as you can see, and down here are all of the loaders and renderers, which kind of have this separate job of actually rendering things on the map. It's sort of where the data turns into visuals, where the rubber meets the road, so to speak. And so this is really demonstrating separation of concerns and my devotion to object-oriented programming in this game. And so to even highlight that further, in data, we're organizing all of this visual data in what's called a biome data scriptable object. And that's what you're seeing here on the right. All of these fields I have exposed that allow me to adjust how this map is rendered on the fly. From tile classification rules, at what sort of height is what material loaded, I can edit that here. And so, we're going up from water to grass to tall grass to stone, or, hills or whatnot. And here is a sort of a focal point elevation system that allows me to define a place on the map that I want the tiles to rise or even fall off toward. I can invert the process here. And all of that is done in the scriptable object. And down here as well, I can adjust all of the environmental effects that are associated with this biome by building what's called an environmental profile. And that's what I have here. And as you can see, all of the effects that are being rendered, such as these dust motes that are emitting from the top of the grass, or the rain falling on certain tiles, all of that's handled and adjustable here. It was really important to me that when I was writing these shaders, I wrote them in a dynamic way that I could adjust this and not hard code anything, because the entire point of this project was to be a shader suite that I could potentially give to people to use in their own projects that are of a similar scope. And that's probably what I'm most proud of, outside of figuring out how all the math works, is making it dynamic and adjustable. Not everything looks perfect when adjusted, but it does allow for a lot of control over the way the effects look. So that's a sort of highlighting the architecture milestone. But let's dive deeper into sort of how the code works for some of these things. And first we'll look at how the common terrain vertex shader works. And by that I mean the shader that is handling the geometric data for each of these little unit tiles. And so I'll quickly jump over to code here. And I want to show you just like how I've done this architecturally. So this is the vertex shader, and a lot of this you can see are functions that do something to the geometry that we can pass down to the other fragment shaders, which are the shaders that will ultimately handle the way the individual pixels are colored. So first, we are doing things with the geometry and the vertices, and then we are coloring them. This is how GPU pipelines work. And let's just do a couple of very simple examples here. This one returns the distance from an edge of the tile in object space. So this allows us to do all sorts of fun, important things later on, like when I want to outline a tile that's selected or highlighted, I want to be able to know which part of those vertices to highlight. And so we're giving this callback function, basically. We're handing this function down to the other shaders that can then have that. Similarly, this is a very simple one that just tells us, is the fragment on the top face of the tile, which is very important for this project, because most of what is happening on the top face of these tiles, right? Highlighting, mousing over them. We're handling what's on top, and that's handled from this dot product right here. And now we'll jump into the next level, which is the fragment shaders of each of these different base shaders. I won't go into all of them, but we'll quickly go over some of the things that I'm proud of in the grasslit shader. So I'll jump back and just show you again what I'm talking about. That's these green tiles here, not these yellow-green ones, but these. And they have a wrapped diffuse lighting around them, as well as a wind effect. So we'll go over those really quick. So basic lighting cuts a surface straight to black once it turns from the light. Harsh on a field of thousands of angled grass blades. We want to be able to soften that look. And so, let's see, from here to here, basically what we're doing is we're gating the softening using the blade's course direction, not its jittery detailed one. So fine surface bumps can't leak onto a face actually turned away from the light. So even though that we're using the flat lit look, which basically means that each side of the cube defaults to a specific color, we're tricking that here. We're allowing some of the extra light to bleed onto the side surfaces, which makes everything look a little bit softer. And then we're exposing some properties here, like wrap diffuse, which is helping us figure out how far down the sides we want to go, and the intensity of the effect. The other thing is the wind effect. So I wanted to figure out how to make grass look like it was swaying on a flat three-dimensional cube, which was kind of tricky. So the way that I did that was the wind effect is being done by just applying a double sine wave of light across the top. And I'll show you how that looks real quick. We can zero in on it if we turn off some of these effects. Here we go. Okay, so we'll zoom in a little bit. So you can see here, kind of, if you look closely at the grass tiles, the light is sort of moving in a natural wave across the top, and that's what you get from applying this double sine wave to the top. And I'm just changing the color basically to cheat the effect. Okay, from there, let's go look at some of the environmental VFX and how that's working. And then after that, we will jump into the demo and go from there. Okay, jumping back into the code. I want to go over quickly the heat distortion effect that I have for my molten tiles that I'll show you in a second. The way that I'm handling all the environmental effects is that we're injecting quads that are basically just transparent planes above each of the tiles. And that allows us to grab some screen space that we can manipulate. So, for instance, the rain is actually just large quads that are standing above the tiles, and that's how we're manipulating that screen space up there to drop the rain down on the tiles. And that breakthrough happened with heat distortion, which I'll show here. So we come inside of the heat distortion shader, and we're first grabbing the screen space coordinates of those quads that I just mentioned. And then we're basically just applying a bunch of crazy noise to them to make them look like that heat distortion effect that you would see right above a flame. And then we're returning it down here. So it's pretty simple once we apply the fractal Brownian motion, which is, again, it's just running a bunch of layers of noise through them. And I'll show you that in effect right now. So first we need to load a molten tile effect. Okay. Waiting for it to hit. There we go. Okay, so you can see above the molten tiles the heat effect rising off of them, and that's what I just showed you in code. And so a similar thing is happening with all of these particle effects that are falling down on the tiles as well. We're using the same sort of grabbing screen space with these quads, and then we're just doing different effects. The heat distortion rises up and is transparent, whereas these little particles are inverting that. They're falling down and they're opaque. Okay, now that we've gotten some of the technical details out of the way, let's have a little fun and play the game, and I can show you some of the graphics and the different biomes and things that I'm proud of. So you start in this menu, and we can quit or start the game. And when we click start, we will automatically generate a map of a random biome. And so let's see what we get. So we got the polar biome here, with the ice effect and the Voronoi noise as the cracks. And let's go ahead and load a different one. Okay, here's the volcanic biome. And let's see if we can cycle through all of them, just so we can show them all off. Here is the swamp biome with a fungal effect. You can see the purple spores floating upwards off of them. And some sort of dark, murky water here that our heroes have spawned in. Okay, and let's try to get the grasslands one back again by quickly cycling through. And you can see how fast everything loads, too. It's very performant. Okay, so we got another grasslands one here, and I think it's maybe the best one to end on. So we'll quickly do a playthrough and try to beat the game real quick. I'll have this guy teleport over here. Instinctives are what I've chosen to call the spells in this game. And then we'll have him move over here. We'll have this guy get in range for... He's got some powerful ranged attacks. And then this guy will be our main defender. When we move him in position, we'll be able to taunt them so that all of the enemies attack him. You can see the AI running for our poor little rogue over here in the corner who has not very many defenses. But he does have a bow and can destroy them from range. So we got that guy down. Can now start focusing on these harder ones. We're going to jump this guy deep into enemy territory and taunt them all. So this is a self-cast one. And now we should be able to just pick them off at range while they all focus our knight in blue. Eventually, there will be VFX for everything, for the actual actions that they take, animation, and character models, and spell VFX was a bit beyond the scope of this project, getting it done in 5 weeks. But I will continue with the project and get it to that point eventually. Be much easier now that I can iterate quickly. Okay, we're almost winning here. Let's move him over there so you can see the enemies chase him. Do a couple of ranged attacks. Oh, he must have been outside of the range of the taunt. Okay. And then finally, should be able to get him from here. Alright, and there's our victory screen. Okay, and that is a look at my game, Tarnished Crown. I really hope you've enjoyed this walkthrough. I'm very proud of the from-scratch shader pipeline that I wrote, all the hand-built system stack, and this playable battle loop. Again, thank you so much for watching, and I hope you have a great summer.